Okay, let's use the RSA coding with a combination of the ASCII conversion between letters and numbers. This is not the most secure method, but is getting very close to modern encryption techniques. So, we want to send the word joy to somebody. We look up that person's information. They have their public key 5 and their N 2021. So that is public, and we will send this information after we code it to them. They have their own private key that works with this public information so they can decode it. But without the private key that works with this public information, that information is gibberish. So if you wanted to do this yourself, you would need to come up with a set of public key and private key information that gives you a one-to-one correspondence with the alphabet. And that's not so easy to do, but it is possible. All right, so first off, joy. We look up the ASCII numbers for these letters. 74, 79, and 89. This table is just for the uppercase letters. There's lowercase, there's punctuations and symbols and all sorts of things. There's a huge database of the ASCII codes. So we're converting from letters to numbers, and then we're converting from numbers to coded messaging using the RSA encryption. So the M is the message, the E is the exponent. Now this is usually G to the N mod P. That's the basic thing, but in this case it's using it so that the G is the message, the N is the exponent, and the P is the larger of the N value that they're giving us. Okay, so we have 74 to the 5th mod 2021. And here it would be 79 to the 5th mod 2021. And 89 to the 5th mod 2021. Now this question says use an online modular exponent calculator, and they do exist. This link isn't active because I just screen printed it, but the notes that is. However, you don't need to do that because I was careful in setting up the E and N and D so that these numbers aren't too large. So we could actually work this out. First off, 74 is smaller than the 2021, so our exponent rule would not help. So we just go directly 74 to the 5th. Huge. Divided by 2021. Subtract the whole numbers part. And then multiply by 21. And know that there's going to be a rounding error. This is 1170. Similarly, we go through each one of these. And now let me demonstrate the calculator. So A is the 79. B is the exponent, 5. And P, the prime number, 2021. And calculate. 1038. So it's easy to use these calculators, but again, we want to make sure that we can use the tools we have available and practice the skills from the module. $71. And let me double check this one, since it's not hard to do. This is 89, 5, 2021. 71. So this is doing all the hard work in the background, not making any rounding errors, and you can have huge numbers, and it works it out just fine. Whereas your calculator, this is way, way, way too big. Even if we did the exponent rule, it still might be too big. So these calculators online are very useful, and you should not have numbers so big that you can't use your calculator on the tests. So what we would do is we would send this person with the public key that code. They would have the appropriate D value, which we don't know, that would allow them to decrypt this one to get back that we sent them a little bit of joy. All right, I hope this video sends a little bit of joy to you as well, and I hope this helps.